Hello everyone, welcome to our channel Electrical and Electronic Line. Today I will discuss you about the two more basic Boolean operations that are AND operations and not operations. Let first discuss about the AND operation. What does this AND operation operate, or how does the AND operation operate? Here I have shown you the truth table of this AND operation. In this case, these two inputs 0. After multiplying, the output will be 0. One input is 0 and the other is 1. The multiplication output is 0, and in the same way, in this case, the multiplication is the 0, the output is 0. When the two inputs will be 1, then we get the output is 1. So it implies this AND operation implies the simple algebraic multiplication, and this AND gate output is equal to the AND product. This type of a product is called the AND product. And these two inputs are the logic inputs, logically 0 and logically 1. We always considered we always consider the logical inputs in this digital electronics course. Okay, here in our previous lecture, I have told you that this logically 1 means a high voltage or a high input, and this logically 0 means the low input or the lower voltage in the various cases. Now let's consider a circuit which contain two switch and a bulb. Pardon my mistake, as I chose here my computer pen to draw this circuit. Which now this circuit contains two switch. Okay. I'm really sorry. Give me time to modify this. Now when these two switches are on, this light will be flamed up. So this is an example of AND operation, and the Boolean expression for AND operation is like, oh sorry, I'm extremely sorry because I chose the computer pen. Now Boolean operation here is the Boolean expression for AND operation is. Now let's talk about the NOT operation. The NOT operation is unlike the OR and AND operations because it can be performed on a single input variable. For example, if their variable is subjected to the NOT operation, the result X can be expressed as this A bar. Okay, It is commonly known as sometimes the NOT circuit or inverter. What is the symbol for this? Let's try to understand it. So sorry. Here is the NOT circuit. Which the input is A and the output will be A bar. Is always the opposite value of this input. Okay, and the presence of this small circle always denotes the inversion. Okay, this always the inversion, and this total circuit is known as the NOT circuit. If this the input will be 0, if the input is 0, the output will be 1, and if the input is 1, the output will be 0. Always it is opposite to each other. Now, the following figure shows the symbol for a NOT circuit, which is more commonly called as inverter. This circuit always has only a single input, and its output logic level is always opposite to the logic level of this input. It inverts or complements the input signal at all points on the waveform, so that whenever the input is 0, output equals 1, and the vice versa. I have gave you a brief explanation on this NOT circuit. Okay, now let's give you some example, and beautiful example, or sorry, let's give you an example on the NOT circuit. This following figure shows a typical application of the NOT gate. The push button is where to produce a logic 1, 2 when it is pressed. Sometimes we want to know if the push button is not being pressed, and so this circuit provides an expression that is true when the button is not pressed. Actually, this figure indicating a button is not pressed when its output is true. Now, this represents what it implies. Okay, when we press this button, that means logic level 1, and then the output become not pressed, which is a logic level false. When the button is pressed, the output will be not pressed. That indicates the logic level is 0. And when this button is not pressed, then the output will be pressed, and this output will be indicated the logic level 2 or 1 for that case. Now here is the summary for Boolean operations. The rules for the OR and NOT operations may be summarized in this way. I hope these basic concepts will help you to grasp the next concept of digital electronics. So thanks for watching.